Hello, Hanman. Thank you for joining. Hello, Venjan. Hello, Nand. Nice seeing you connected. Okay, so and John is joining. Okay, I think we have all speakers for today, right? Yeah. Welcome to the computational chemistry class. Thank you for continuing to support it by visiting and coming. So we are having our first midterm today, and it is chopped between 2 days because schedule conflicts. We are covering model building and visualization skills, and by presenting a little skill at a time to each other and letting the rest of the class watch it, it will be the best instruction so that we all will be on the same page and will apply these skills towards your projects in the future. So, hello, John. Nice seeing you connected.
Hello.
Hello. I hope everyone, yeah, since everyone answers, I think you hear us in class. Let me share screen. So there are 5 presentations for Monday. So one of the class attendees is like delaying for a medical condition, another has schedule conflict, but everyone who is registered is able to present today. So is it right that we have Venjan, John, Said, Payman, and Anand, right? Okay, so here are the talks in their order. Let me double check if you are, if you all are co-hosts, just in case. Amir co-host, Anand co-host, Hanman. I think Hanman presents tomorrow, but it's easier for me to make everyone co-hosts. And Venjan, make co-host, yes. So if you are speaking through Zoom, just share screen and start your presentation. If you are in class, proceed to the stage, and you have seen there is a all slides are uploaded here. Just double click and start presenting. Please try to limit your presentation within 5 minutes. If I will try to watch time, and if it takes longer, at least for those who are in class, I will try to push you from the stage. If you are online, I don't know which sanctions I can do. Just maybe stop sharing or just gently type, but try to be within 5 minutes. If time questions are welcome. If we spend time on questions, it's less limited, but the actual presentation, we do not go over too complicated subjects. Everything should be compressible. So the numbers are a little strange, but if we add them together with presentations from tomorrow, they will make a continuous logical line. And if time allows, maybe later I will process and chop them into a single video with numbers one after another. So the talks are intended to be arranged from Linux skills to building models to measuring and visualizing and converting, right? So the first speaker is Venjan. So I know that you have like 24 slides, so it's especially for you. Please try to stay within 5 minutes, if possible.
Okay, I'll limit my time. Yeah.
Okay.
Can you see my screen?
Yes, we can.
Okay. Hello everyone, I'm Wenjian from civil engineering, and today I'll talk about open account on CCAST.
Venjan, would you please swap displays? You're showing presenters display instead of.
Sorry?
Can you see the upper top line? It has like end show tips swap displays. Can you?
Where?
Yeah.
Here?
Yeah, please click.
Okay.
Yeah, much better. Thank you so much.
Thank you. Today we'll talk about open account on CCAST and NERSI. The first one is CCAST. It's a simplified name of Center for Computationally Assisted Science Technology. And if we want to open account, firstly check out our eligibility requirements. It's only available to NDSU faculty, staff, or students. And one could read CCAST user policies in the following link to know more about CCAST. And the steps to open an account. The first step is to fill out an account application form online in this link. And the question could including are you belong to NDSU, and type your full name, type NDSU email address, choose your role, choose your type your department, and briefly describe your research projects. Let me show an example. For me, the research project could be polymer clay nanocomposite, and the software I plan to use could including labs, VMD, MATLAB, and others. And then type your email address or faculty advisor. It's recommended but not required. And the sign agreement policy, and will receive the verification email. So in this email, CCAST told us once our account has been approved, generally by our sponsor or advisor, we'll receive another email to for CCAST account activation. What's important is your user ID is your full name, and the password is the same as your NDSU password. After we active our account, we can connect it to CCAST. For Windows computer, the app could be PuTTY, and for Mac or Linux computer, it could be Terminal, and it has a similar formulation to the one we used in the first lab lecture, the photon one. So it's SSH formulation. And the process could be summarized by fill out an application form, sponsor email, confirmation, and connecting. Another one is NERSI. It's National Energy Research Scientific Computing Center. We didn't go to this step yet in our course, so I asked some information from previous students of this course, the last year previous students. And it's another kind of high performance computing user facility. If we need to use this, we need to we could get an email from Dr. Killing, and he will tell us the open account address, and fill out an application form online. Is similar to CCAST, and we could have another project name all the same. So it will be in the Dr. Killing's email. And after we type this information, we will receive another submission back information to tell us received our submission. So here is the open account on NERSI, and this is my presentation. If you have any questions, please feel free to ask.
Yeah, many thanks, Venjan, and everyone. Please join me in uploading to the speaker. So, any questions in class? any questions on the line. So if you have questions, preferably just start speaking, or if you're not sure, you can just type questions in the chat line. Venjan, I do have technical question to you.
Yeah, go ahead.
So were you able, are there any difficulties to connect to CCAST through MobiXterm? Did you try?
I didn't try that yet.
Okay, so it's just an idea for everyone. It's not mandated, but it can be useful if you prefer CCAST. And second thing, it's not like a question, it's a suggestion. Did you try CCAST on demand? Did you hear about it?
Not yet on demand.
Okay. Okay, so let me bring it up. If you are already CCAST user, so if you plan to use it, when you just in the Google search, you type CCAST on demand, and it will bring you to the navigation window where one can log into CCAST terminal or use graphically enabled applications such as Gauss View or VMD directly on CCAST and or MATLAB. So there is a way to log in even without any specific software on your computer through the web service. And it's a little slower than MobiXterm, but I use it as a backup, and it's recommended. So another call to Venjan. Questions 1, questions 2, questions 3. Please join me thanking Venjan once again.
Okay, thank you.
Thank you. You can stop sharing.
Okay.
So I didn't miss any questions in the chat line. Okay. The next presenter is John. So John, would you like to share your...
Yes, I can. Just give me 1 second. Okay, can you all see? It should be the full presentation, or not the full presentation, but the PowerPoint window.
Yeah, it's PowerPoint in the editing.
Oh, sorry. Okay. Share. No, okay, I was right the first time.
No, it's okay. As soon as I stop sharing.
1 sec.
Oh, I see you were watching how much time for each slide.
Yes, yeah, I was trying to.
That's cool.
Which one are you guys seeing?
Pencil, carbon nanotubes, pencil, and your name.
Okay, and sorry, it's full screen?
Yes, full screen.
Okay, all right, sorry.
That's okay, that's okay. Go ahead.
So today I'm going to be talking about carbon nanotubes, and mainly how to, 1, understand the name of what carbon nanotubes, how they're structured, and 2, how you actually model that using Gauss View. So by now we should all know that the lead in your pencil is not lead at all. It's actually carbon, and it's a special stable type of carbon called graphite. And if you could zoom in with a microscope, you would see that this graphite is many layers of a single carbon sheet called graphene. And each carbon in a graphene layer is strongly connected to all the other carbons in its layer, but it's much more weakly connected to carbons in the layer below and the layer above. And so if you're able to isolate one of these sheets and fold the sheet up, that's turning a graphite sheet into a carbon nanotube. And so the complexity, or I guess one of the aspects of the complexity, is just like you have infinitely many ways to fold a piece of paper, there are nearly as many ways to fold up a carbon nanotube. So carbon nanotubes, exhibit a crazy variety of chemical properties based on their structure and functionalization, but I won't talk about functionalization. They've been used for energy storage, boat hulls, vehicle parts, electronics, and a bunch of other things. And so the way we actually derive the names of the carbon nanotubes is defined by how we rolled up that original sheet. And so we're going to talk about them as an ordered pair of 2 points on a lattice. So here we're going to define two axes, our N and our M. The first one is going to start at 0, 0, and every time you move across to a adjacent, or not adjacent, a carbon 2 over, you're going to define that as the next point on N. And you can do that all the way across for all of your N points, for all of your M equals 0 points, and the same for all of your M points. And then moving across the lattice is fairly easy. Following, if you start at 0 and trace this whole hexagon, then your next lattice point is going to be at the connection to that one. So here we have 1, 1, 2, 2, and 3, 3. These are two very important groups. All of the points, all of the lattice points, all of the carbon nanotubes that are defined when N and M are equal to each other are going to give us an armchair structure, wherein the top of the carbon nanotube or the ends are much more smooth. Whereas if we're following on the M equals 0, we end up with the zigzag structure of a carbon nanotube, and these will all be defined as a 1, 0, 2, 0, 3, 0, or 4, 0 nanotube. And then finally, moving to points that are not along either the black or blue line result in a chiral nanotube. And the big asterisk when we talk about chiral nanotubes is there's two directions that the nanotube can turn, which is why it's called chiral. So if we have 2 points on the lattice called 2, 4 up at the top and 4, 2, what that is saying is that if we have this chiral tube here and it's spinning counterclockwise as the 2, 4, then the 4, 2 nanotube would have the exact same structure, except it would be spiraling clockwise. So if you just swap the ordered pair, then you can reverse the chirality as long as it's not along the black or the blue line. And so I only modeled one nanotube, and it was the 3, 3, just because it was fairly simple. And the way you do that, once you know what nanotube you want, what that ordered pair is, what the chirality is, then you can use TubeGen, which is a really nice piece of software provided by the University of Delaware. The URL is at the top. Also, if you just do a quick Google search TubeGen, you get right there. Important bits to pay attention to. Obviously, we want a 3, 3 nanotube, so we have a 3, 3 chirality there. Bond length and atomic basis is fine. We're just working with carbon. What we're really interested in is 1, the cell gutter, and 2, the replication count. And I apologize, I see that I've gone over 5. I'll go quickly. In essence, the cell gutter is the buffer region between adjacent nanotubes. So we're saying that each nanotube itself is going to have 1.67 blah, blah, blahs buffer between that and before the next one starts. The gutter direction is 0 in the A3 direction, or the K axis, and that's because we want there to be no gap, because this is the orientation that our nanotube is going to grow. And then finally, cell replication count. I and J are 1 because we want 1 nanotube, and K is going to be 3 because I want it to be 1 nanotube of length 3. So we're going to have a 3, 3 nanotube, 3 length. Format and units, not super important. There are a bunch of different ones. I find Gaussian the easiest to use because you can copy and paste the output into a GJV, a Gaussian view file, and you can just load it right up. And so the first thing I did was made a carbon, or a graphene sheet of the appropriate length, and kind of just show the axis that we're revolving it around. And here is that 3, 3 nanotube of 3 height, or 3 like unit lengths. And then additionally, if you're interested in clusters of of nanotubes instead of just an isolated one itself, you can increase the A and J or I and J, and you can extend the amount of nanotubes you have. Any questions about the nanotubes?
Okay, please join me in thanking John. Any questions in class? Yes, no? Any questions online? I do have at least two.
Okay.
Yeah, thank you. First one, how do you identify a place of your talk in the overall stream of this presentations? Like most of people are showing how to log into cluster or how to draw and copy paste units, and you are doing something else. Like, why don't you taught us how to draw carbon nanotubes by clicking on spheres in Gauss view?
Why I didn't talk about making carbon nanotubes like click by click?
Why?
It would be rather tedious to click in every single carbon in the tube, or even if it's just a sheet, and to make sure that all of the orientation and spatial, what's the word I'm looking for? I feel like all of the interatomic distances would be messed up if I tried to do it by hand.
That's correct. That's correct. Everyone agrees, right? And also there is a factor that if one would need to draw graphene flake, it's possible because it's flat and all carbons are sp2. But if you want a tilted sp2, when the symmetry is sp2, bond are of the order 1.5, but it is tilted, then angles are different, and how to match them is not easy. So a summary that for situations when hand drawing fails, there are databases. So it's your place in the stream. Yeah, thank you. And a second question, it's not related to our oral stream, but you so interestingly and nicely told about nanotubes, so that I'm just curious. Nanotubes can exhibit different conductivity properties. They can be either metals, conduct electricity without resistivity, or semiconductors. So is there any connection between their conductivity and chirality when you were just scanning through background information?
I was kind of just scanning through background information. I don't know like the effective difference between chirality or chirality on conductance versus just like the size of the nanotube, if it's crown or staggered, you know.
Okay, let's quickly look on it. Can you please go back to your
Absolutely.
Yeah, enough. The image with flake and nanotube together. Next, just forward. Yes. Okay. So there, if one looks onto your what is armchair or
Oh,
3?
sorry.
How do you call it?
The armchair is zigzag, and then chiral.
Okay.
We're looking at the 3-3, so we're looking at the armchair because we've got kind of these ridges that go up and down. You can see it better on the graphene itself, whereas jagged would be alternating up and down on each carbon. Okay, so if we look on this line near yellow line, do you see my finger on the camera? Here. Yes. Yep. So you see, as we go from your blue sphere higher up along the line, there are conjugated bonds along this line, and it makes it highly conductive. If one rotate it, it is a little less conductive semiconductor. So when the indices are the same, it is conductive. When they're different, they're not. And there is a rule of if these two numbers can be divided without the rest onto each other in integers. It's just for curiosity. But okay, so as you move along that n equals m line all of those would be good conductors, but if you go on to the N0, bad?
N0 will be semiconductor.
Oh, okay. So follow-up question, where do chiral ones fit into this scenario?
Most chiral are semiconductors.
Okay, all right. Thank you, sorry.
Okay, yeah. Haley, did you wanted to ask, you just joined, did you ask to ask something to John?
Nope, I am just wanting to listen.
Okay, then everyone please join me in thanking John. John, you are welcome to stop sharing.
Yes. And then I'm going to fill up my water bottle real quick, but I'll be right back.
Sure, then we will not surprise that you're not in front of the camera. So the next presenter is Said, and let's start sharing. Yes. Wow.
Can I just hold it?
You can hold around, and I think it is a smart camera that will automatically focus there.
Okay. Am I in the camera?
I think so. Let's ask those who are online. John, do
Can you
you
see me, everyone? All right. Okay.
Yep, I can see you.
Okay. So everyone, my name is Sayed On, and today I'm presenting on the topic copy paste molecular fragments in the Gauss field. So starting with the briefly introduction of the Gauss field, we all know that it's just a computer program which are using to build electronic models and the structure of molecules. And some other calculations such as the bond angles, bond distances, and the energy associated with them. And it's a good computational technique, and which is like it's very quicker. It result give very faster and accurate. So this is the basic screen of the Gauss view software. And here you can see there are three screens. The right one is the view screen on which we can view the molecular fragment which we made. And on the left side, we have the upper screen, which is just the basic command screen on which you can give the command on the screen. And the lower screen is just the element fragments in which you can choose any of the element to start to build your required molecule. And you can also access the Gauss view software in the command lines in the Mobextrum. You just have to write the gview.exe and you can go directly to the software. So coming towards the topic, how we can copy paste molecules in the Gauss field. To start with the copy pasting, you just have to build any molecule in your command view screen. Like this, I have prepared a benzene molecule, and then you can just press A on your keyboard, and you will like select all the atoms of the given molecule. So if you have more than one molecule and you want to select any particular atom on your molecule, then you have to point with your mouse cursor on the selective atom you want just to copy. And then you will press Ctrl C, and all the elements you have selected will copy to the clipboard. And then you can just see here the clipboard showing the atoms you copied on the clipboard. And then you can just paste the molecule on your screen by pointing out anywhere on the screen. Like this, I pasted first different the same molecule on the different screen, and then on the second screen you can see I pasted the molecule on the right of the carbon atom to bond these two, and I make the cluster of 7 benzene rings. This is another orientation of the same molecule. Just ended actually. No, I am still continuing. Okay, can you see the screen?
Yes.
Okay, so here you can also copy paste the your molecular. Just type, click right on your mouse, and you will follow the screen on which you can see the when you go to the page, you have three options. We state that add to molecular groups. It means if you control V on your keyboard, you will add another molecule, but not on the same screen, but on the different screen, and which can you can see that like I pasted 3 times, and you can and there are 3 screens with the same molecule. In this way, you can just see your molecule in different orientation. And when you just click the replace molecule, in this way, you are just replacing the molecule which is on screen with your copied. And on the third one is the apparent molecule. In this way, you are just adding molecule to the same, but it won't show in the screen. It will just add up into your atoms count. And so this is all from my side, and you can ask questions.
Okay, please join me in thanking Said. Any questions in the class? Anyone having questions online, please go ahead and ask Said.
Yeah, I think yes, if there is questions raising hand.
Shahid,
Yes, please. Go ahead.
nice presentation. I have one question. Once we select the molecule,
All right.
all right, so we are just directly pasting that molecule in the viewer mode, means in viewer window, right?
Yes.
So can we select any one of the atom from it and then we can paste it there so
Yes.
it can get attached?
Yeah. You just have to click on the particular atom, and then you can just add it on your desired position.
Okay, so in this way it will get attached directly.
Yeah, you can attach to any of the position of the given molecule.
Okay.
It's very simple. You just have to copy paste with your mouse or keyboard.
Okay.
Yeah. Thank you.
Thank you.
More questions? More questions one? More questions two? More questions three? Please join me in thanking Said once again. And the next presenter is again in the classroom, right? So Clayman, would you please go ahead?
Hello, everyone. My name is Peyman. I'm a PhD student in Civil Engineering Department. Today, I'm going to talk about editing molecular geometry in command line in Mobile Extern. So why do we need this? As Dr. Killing and John mentioned before, sometimes it's better to edit molecules in the editing format because we can edit molecules in 2 ways. First of all, using GView, and sometimes it's better to have the coordinates of the molecules and import those coordinates in the software. So first of all, for editing coordinates in geometry, first of all, we need to choose the directory that the save file exists in it. Then for seeing the list of the files, we need to type the following command. So by typing ls, we can see the list of files. From that list, we need to choose the name of the file and see its content. For seeing its content, we can use the more command. So when you type more, and then, for example, here, the name of the file is newmodel.pdb. We can see the content of that file. There is an example in the next page. And as you see, the content of the file has coordinates, X, Y, Z, and name of the atoms. This environment is not editing mode. For editing the file, it is suggested that first save the original and source file. You can use the CP command that copies the main file. And for doing this, you type CP, the name of the file, and then choose the name of the copy file. And then you can edit the content of the copied file. Then for going to the editing environment, you can use the VI command. By typing a VI command, you will enter to the editing mode. And as you see in the editing mode, the coordinates and all the numbers are in the red color. So how can we edit these numbers? So you need to press I on the keyboard to select the insert mode. When you press I, you can change the coordinates of the atoms. For example, you can hover over on the, for example, X, Y, Z coordinates and change it. Here, I changed the -4 to -40. And when you're done with the editing, you can press escape key on the keyboard. And then for exiting the editing environment, you need to type column WQ. And by typing this, you will exit from the editing mode and the file will be saved. So that's a procedure that you can edit the coordinates of the atoms. Please let me know if you have any question.
Okay, let's join thanking Payman. So any questions in the class? No. Any questions online? Please type or speak. I have a brief question. If you made this change, you didn't show the outcome. Like, what is this change of the X coordinate? How? Just explain what you see on if you open this in Gauss view.
When you change the coordinate, actually, it changed the in this case it changed the X coordinate of the atom C. So you expected that there will be more distance between the initial position of that C atom, and you see some lengthening of the atom to its original one.
Okay.
So I think you're right. I need to put the image of those changes, but yeah, sorry about that.
That's fine. That's okay. Okay. Please join me thanking Payman once again. Thank you. And there could be, yes, I would upload to Payman in this form, as everyone does online. Okay, and last but not least, for today's session is Anand. Anand, would you please share screen? Okay, and yeah, go ahead to the presentation. Okay, floor is yours.
Yeah, hello all. I'm Anand and I am going to present on the JMOL. So actually JMOL is a computer software that is used for the modeling of chemical structures in the three-dimensional manner. And it is written in the programming language Java. So if you want to use this on your Windows, so you have to like download one Java platform. That's why I also downloaded. So that's why on my computer it is now working. And it is a free and open source software. So it is good to use, and it is a popular feature in an applet that can be integrated into web pages to different molecules as a variety. And it supports a wide range of chemical formats like PDB, CIF, MDL, mol file, and CML. Okay, so if you open the JMOL application window, So at the upper side, it is like menu bar. It is having so many options, and there is a toolbar. There are specific functions of the menu bar, and it is the display area that is known as Jmol panel. So if you want to use it, just go and to the this model file, and you will get this panel, and then you have what you have to do. You just click it and you will get that simple methane structure. Then if you want to add some more carbon or other molecules, so go at this panel, and there is a option of adding or delete, or you can add several functional groups. So these options are there in this panel. So if you want to save it, just go to this panel and mol file, and it will save, and you can save at your desktop or any location. So if you want to add like functional groups, so again you have to go to the molecular function level, and there is one panel, and you can add different function. Like I added this. This is the oxygen OH group, hydroxyl group, and this is the chlorine. It is in the green color. Chlorine is green color, and oxygen is in red color. So there is also an option of console window, so that you can type your JavaScript and it will give the molecular structures. So it is available in the file menu. So click on the file menu, and you will get the console like this. And again, you will get the 3D structures of the biomolecules from the database. You have to open the file and get PDP, and you directly go to the PDP on the Google, and you will get the PDP structure. Like you will get the 4-digit code, and you just type it, and it will directly take from the website. So it is like the human insulin molecule. So you can add or delete any kind of molecule. Like if you want to create other structures, or it is a ball and line structure, but you can, the style you can change it. Like in the console panel, you can just click into the console, go to the style, and it will give the different structures. So if you want to take the different type of other molecules from the database, so go to the PubChem and get mol. The files are like the inputs. You can take it like common name, IUPAC name, or CAS number, CID, NG identifier, or smiles. So you can take any type of output, just type it, and it will automatically take it from the database of that website. Okay, thank you.
Please join me in thanking Anand. So where is this way to, yes, reactions, upload. So are there any questions to Anand in the class? No? Piman? No? So any questions online? I do have a brief question, which is kind of self-evident. Anand, you did show how to build models, but if you need to modify existing model, or if you need to save and read, can you just comment on how to, you mentioned that it reads any other format, but did you try saving? Can you save into browser? Which buttons should we, can you show the once again, and just navigate us which buttons should one click to save the model that you have created?
Just a minute, I can directly, even I'm not in the class. Okay, just go to the console menu, not on console.
Will you please share screen and make a little demonstration?
Yeah, it is a really good option. Okay, how to screen. Okay. So my screen is visible?
Yes.
Okay. So again, directly I'm opening it. Okay. So these are the different menus. Open the model kit. So directly I will go to the model kit. It will give the structure of like methane. And if you want to add any of the molecules, so it will give you the carbon. And if you want to like yeah, is the model kit. And if you want to save it, so save it, save file, and anywhere you can save it, like on your desktop or any library or chemical order. I'm saving it. So
But if which formats for saving? Like if you want it to save in PDB or in Gaussian input file to be readable, can you just slowly go into?
yeah, okay. Okay, sorry. So if I want to save the file, so the option is mol file. And if I can even save it in like JPG format also. Like
No.
okay,
JPG
okay.
is not allows us to use it for computation.
Yeah.
Let's
Mol
once again,
file.
File, save file, click file in the menu, save state. Check what will, if you go save, not file, save state, and select no. There should, well, okay, it will be a little homework for all of us, how to save it in the Gaussian format. It is possible, and it's just a couple of clicks. And if adding this functionality, it will make it much stronger, not only visualizing, but also editing files. But are there more questions to Anand?
Yeah.
More questions one, more questions two, more questions three. I think there is no more questions. Let's thank Anand. It's really useful piece of software that we all
Thank
can
you.
use. So many thanks to all presenters and visitors. I'm pleased to see that few people who originally told that cannot come on Monday were able to join. Thank you. The meeting, as a plan minimum, I will just do as usual, post recordings of today and tomorrow meetings. But if time allows, I will try to do video editing and chop so that they will go from 1 to 3 in a more logical sense. It takes time, but it would be good. Or and in the future we can do similar things as a editing video together. But right now I'll do it myself. So meeting is done. Everyone is welcome to depart and disconnect. Those who present tomorrow, if you haven't sent your slides, please send by tonight, by midnight. And tomorrow at 11, we will start presentation session. Tomorrow we will have, I think, 8 presenters. So today, you saw it. It's possible to do within 5 minutes, but it is like takes time. Tomorrow it will be, we should watch time more carefully. So 8 presenters in 1 hour means like 40 minutes plus some questions. So we will be sharply, it's barely possible to do in 1 hour, but we'll try. So many thanks. I look forward to seeing you tomorrow, and have a nice, it's not yet weekend. Have a good night.
Have a good one.
Thank
Thank
you.
you.
Yeah,
Thank you.
Yeah, thank you.
Thank you. Nice presentations.